Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Moore's Algebra I class. Today we are going to start talking about systems of linear equations. And systems are pretty cool. Very simple if you know how to work with linear equations. If you can graph a linear equation, you can recognize the slope, the y-intercept. You can convert a linear equation into slope-intercept form, point-slope form, standard form. You know how to find the x and y intercepts. You're going to be golden. If you don't know how to do that, I suggest strongly that you rewatch and redo the homework for chapter 4. It's going to be very useful and beneficial to you. There's going to be a lot of word problems involved in this chapter. There's going to be a lot of algebra involved in this chapter. But it's all easy and it's all based on what we just learned. I promise you that much. We're going to start by learning how to solve a system by graphing. Now, before we solve a system, what on earth is a system? Well, a system of equations is a set of 2 or more equations. It could be 3, 5, 10, it could be 20 equations. A set of 2 or more equations. It is used when you have 2 or more related unknowns. What's happening here is you're going to have 2 simultaneous linear equations on the same graph. They're going to be working together at the same time. And we need to find the solution of both of those equations. Please remember that a linear system, just a linear system, when we're talking about linear systems, remember we're just talking about y equals mx plus b. Okay? That consists of 2 or more linear equations. A solution of system is the value or set of values, the ordered pairs. Remember that ordered pairs equal the x comma y. So it's for the variables that make all the equations true. So when you find a solution of a system of linear equations, you're finding the point that makes both equations true. You're finding the point that makes both equations valid. So let's check it out. The skill that we're going to learn here today is solving systems by graphing. So I'm not trying to be sarcastic, but when you see 2 equations here, what do you think you have to do if you got to solve them by graphing? You got to graph them. Very good. Very good. Very good. Okay? Ah, that was wrong. I shouldn't have done that yet. The solution is going to be negative 3, 3, but let's show you why. Let's first graph this bad boy in blue. Before I even start, it is okay if you guys get yourselves some different colored pencils to help yourselves understand the different lines. That is fine, and it's actually suggested. When we do linear inequality systems, then it's really going to be important to have 2 different colors. I'll show you how to work with it regardless, but just food for thought, you should think of that. So, okay, let's graph this. My y-intercept is 5, 1, 2, 3, 4, 5. My slope is 2 over 3, so up 1, 2 over 1, 2, 3. Up 1, 2 over 1, 2, 3. Down 1, 2 over 1, 2, 3. Down 1, 2 over 1, 2, 3. Does everyone understand how and why I graphed that? Is that a yes, no, maybe kind of, sort of? Yes, okay, great, thank you. Now I'm going to graph this bad boy. Y equals negative 2x plus 1. Y-intercept is 1. My slope is negative 2 over 3. Down 1, 2 over 1, 2, 3. Down 1, 2 over 1, 2, 3. Let's go backwards. Up 1, 2 over 1, 2, 3. Up 1, 2 over 1, 2, 3. Do you see that you have an intersecting point? That's right here. That's your solution. So your solution is negative 3, 3. Why is that the solution? Because that is the point of intersection of both lines. That is the point where both lines are equal. How can you tell, Mr. Morrow? Is there any way to check this? Yes. Plug this point back into here, and they better be true. So let's check it out. Let's first work with this guy. Y, which is 3, does that equal 2/3 times negative 3 plus 5? Well, 3 equals, that's negative 2 plus 5. Yes, 3 does equal 3, so that works. Now let's try to check for this guy. Y, which is 3, does that equal negative 2/3 times x, which is negative 3, plus 1? This is 3, which equals 6 divided by 3 is 2 plus 1. Yes, 3 does equal 3. So just in case you see the graph and you're like, I think I did something wrong, you can check. You just plug it in. Thank you. Does that make sense, guys? That's it. That's the lesson. Done. Bye. Have a good day. No, I'm just kidding. It is the lesson, but we're going to practice some more. Okay. Excuse me. What happens in this situation? Are these in slope-intercept form?
No.
Are A and B factors of 8? No. Whoever said yes, no, they're not. So I'm going to have to solve for y. So let's solve each of these for y. And that is a skill that we have already learned. Add 3x to both sides. 2y equals 3x plus 8. Divide by 2. Y equals 3/2 x plus 4. And we'll just do this one in red. Subtract x to both sides. 2y equals negative x minus 8 divided by 2. Y equals negative 1/2 x minus 4. Now I have my two equations. Now I can graph them nice and easily. So let's graph my blue one first. Y equals 3/2 x plus 4. 1, 2, 3, 4. Up 1, 2, 3 over 1, 2. Up 1, 2, 3 over 1, 2. Down 1, 2, 3 over 1, 2. Down 1, 2, 3 over 1, 2. That's my line for my blue equation. Now the red. Y equals negative 1/2 x minus 4. My y-intercept is negative 1, 2, 3, 4. My slope is negative 1/2. Down 1 over 1, 2. Down 1 over 1, 2. Up 1 over 1, 2. Up 1 over 1, 2. Up 1 over 1, 2. You got to keep going until you get the intersection. And hey, guess what? There's my intersection right there. At negative 1, 2, 3, 4, negative 2. That is my solution. Negative 4, comma, negative 2. So if you know how to graph and you know how to solve for y, this first lesson is going to be Mickey Mouse. If you don't know how to graph and you don't know how to solve for y, this is going to be very, very arduous for you. That means difficult. Okay? May I continue? You guys on the same page with me? You understand what's going on here? Pretty easy, right? All right, good stuff. God bless you. Okay, find the solution of the system. Okay, what do I got to do here first? Find what? Solve, find, make. Okay, solve for y. Thank you. I got to solve both of these for y. I got to solve both of these for y. So I'm going to subtract x to both sides here. Negative 2y equals negative x plus 4. Divide by negative 2. Y equals 1/2 x minus 2, because that negative 2 goes to here and to here. And then we'll do it in red. This guy over here, we got negative 3x to both sides. Oh, we're done. Y, that looks like an x. I apologize. Y equals negative 3x plus 5. Bless you out there. Yes, sir. Thank you. No, you're welcome, sir. Okay, so let's graph my blue equation. Negative 2 is my y-intercept. My slope is 1/2. Up 1 over 1, 2. Up 1 over 1, 2. Up 1 over 1, 2. Go backwards. Down 1 over 2 to the left. Down 1 over 2 to the left. As you notice, I'm making plenty of points because I want to make sure that they intersect. Now my red one, y-intercept is 5, 1, 2, 3, 4, 5. So down 1, 2, 3 over 1. Down 1, 2, 3 over 1. Down 1, 2, 3 over 1. Boom. That's it. Thank you. Great. No, that's not 3, negative 1. That's 2, negative 1 is my solution. That is the point that satisfies both equations. That is the point that makes both equations true. That is the point that makes both equations equal. Does that make sense? Promise. Okay. Yes, sir. Come again? Okay. I'm already getting laziness. Mr. Moore, if I know it's got to connect downwards, do I have to graph above? Yes, you have to. I want you to do it the right way. Please and thank you. Laziness has no place in mathematics, my friends. I'm sorry, but it really doesn't. Okay, there's an easy solve. I'm going to subtract 2x to both sides. So I got y equals negative 2x plus 4. And my second equation is already in y equals form. So I'm going to graph my red one first. Y-intercept is 4. 1, 2, 3, 4. Down 1, 2 over 1. Down 1, 2 over 1. Down 1, 2 over 1. Go back to the y-intercept. Up 2 over 1 to the left. Up 2 over 1 to the left. Bam. Now my blue one, y-intercept is negative 3. 1, 2, 3. Up 1 over 1, 2, 3. Oh, there we go. Up 1 over 1, 2. Up 1 over 1, 2, 3. Bam. We got it again. My solution equals 1, 2, 3, 2. Negative 3, comma, negative 2. Again, if you plug that in, you have my word that they're going to be equal. Is that making sense over here, my friends? Sir, thank you. Absolutely, I mean positive 3. Great catch. Thank you so much, sir. Well done. Thank you for keeping your eye on the ball. That was my mistake, and I apologize greatly. No excuses. Thank you, brother. Any questions on this besides my mistake? Thank you, guys. And, oh, that's it. We're good. Have a great day. Hope you guys learned a lot. Thank you very much.